Hello, my name is Armani Sarchari. In this video, I am going to explain the machine learning project on bike sharing demand. This project primarily focuses on predicting bike sharing demand using machine learning, which is based on different factors, or which is having different factors like weather conditions, time of the day, seasonality, and holidays. The dataset include both numerical and categorical variable. And in this project contains four steps. One is data cleaning, feature engineering, exploratory data analysis, and model development. The primary goal of or objective of this project is to build an accurate machine learning model to forecast the number of bike rentals at a given time, enabling better planning for bike availability and improving user experience. So, when population grow, so transportation solutions, bikes in many cities. The central issue is predicting the number of bikes needed at a specific location at different times of the day. The problem is compounded by the influence of weather conditions, which is the temperature, humidity, wind speed, which can significantly affect bike uses. Furthermore, factors like holidays or city events introduce regular patterns in bike sharing demand, making it even harder to predict uses accurately. The goal of this project is to design a bike demand prediction model that accounts for various factors influencing bike rentals by analyzing historical bike rental data. With this model, we aim to provide bike sharing companies with a tool to anticipate demand more effectively, ensuring that the right number of bikes is available at the right time and place. Let's start the project. Here I have first imported all necessary libraries in one block. Next, for dataset loading, the dataset which is sole bike data, which is in CSV format, is it I have downloaded and kept in my drive. So that I have used here drive.mount function to mount the particular my drive and to read the particular CSV file or dataset. After retrieving the dataset, I have put or store into bike underscore sharing underscore df dataset. And first I have this is dataset first view. For first view, I have used a head function which will print the first or top 5 rows of the dataset, which has data like this. There are many columns, which is like date, rented by count, hour, temperature, humidity, wind speed, visibility, dew point temperature, solar radiation, rainfall, snowfall, seasons, holiday, functioning day, like this. And to print last 5 rows of the data set, I have used a tail function. And from this, we encountered that there are total 8,760 rows and 14 columns. And the dot columns will print the all column names of the data set. So let's talk about description of the columns. What are the column names and what are the purpose? So first date, the specific day of the bike rental data was recorded. Second, rented bike count, which is here our target variable, and the means the number of bikes rented during the hour. Hour is the hour of the day. The rented record was taken, which is in 0 to 23 format, number format. Temperature is in Celsius. The recorded temperature is in Celsius at the time of rental. And what is the humidity? What is the wind speed? What is the visibility, which is in meter at the time of bike rental? And this is also dew point temperature, the temperature at which moisture begins to condense. Next is solar radiation at the time of rented bike. The amount of solar energy reaching the ground, which is in megajoules per square meter. And rainfall, what is the rainfall? What is the snowfall, which is a millimeter and centimeter? Which season at that time? Holiday or non-holiday? Functioning day or non-functioning day? And here the full description of the data frame or data set, like for each column, the count, mean value, standard deviation value, minimum value, maximum value, and for each quartile values for each columns. Here the info function, the summary of the data frame. And for each column, the what is the data type? Here we can observe that here we have only object, integer type, and float type. Only three types. Okay. Next, unique values. I have printed I have used that cat underscore unique underscore values, which is a user defined function, to print um unique values of each columns, which unique values having by each columns. And here I have as I have uh, observed that the category columns, seasons and holidays are two categorical columns. I have assigned them into the category underscore columns variable, and then I have used that unique value of function which I have defined earlier. By using that function, I have getting the output as the values that are categorical column seasons are taken can taken are for winter, spring, summer, and autumn, and holidays are non-holiday and holiday. These are the unique values of the categorical columns. And I have define another function creator underscore df underscore analysis to the analyze that any column, like here season wise analysis. The month means uh, for each season how many the rental bike counts are there. For that the I have used the creator underscore df underscore analysis function. After applying this function, we are getting that summer is the highest and the winter is the lowest. Okay. So what I have done so far means that we observed that, or we found that records, how many records are, how many columns are, and what is our target variable here. Here target variable is rented by count, and what a numerical, what a category value insets means summer and autumn peak rentals, winter lowest rentals, and weather, extreme cold, rain, snow reduces demand. Functioning day, higher rental object. My next step in this project is data visualization and EDA, exploratory data analysis. In this section, I'm going to explain only. I have so many charts I have discovered, but I will only explain 5 charts out of this. So let's talk about first chart. Our first chart is rented by count by seasons. For each season, how many? From previous analysis, this chart is defined. For this chart, I have used the C1 library, and the function is cns dot bar plot. Here I have used bar plot because that seasons is a categorical data type, categorical data type value or column name. So that for categorical data, bar chart is best for to easy accessible or easy analyze the prediction visualization. Okay, from this visualization uh, we can see that summer, then autumn, then spring, and last winter. The count by per seasons. So let's talk about briefly. Summer and autumn together account for a significant portion of total rentals, indicating strong seasonal dependency. Winters is sharp decline, means people are less people are renting bikes less in winter. So from this chart, we I recommend. I have some recommendations. Like the recommendations are like this: increased bike availability and maintenance during summer and autumn, just because of these seasons are peak seasons for bike rentals. And lunch special offers and discounts in spring to attract customer early and boost rentals. And offer free accessories like rain covers or safety gear during seasons with unpredictable weather, like spring and autumn. And my next chart is bike rentals on holidays versus non-holidays. This is also a categorical data, so that I have used a bar chart. For this also, I have used C1 library. And for x-axis, I have used holiday. Y-axis, the target value, which is a rented bike count. We can see that people are rent bike on no holidays more. Means the normal working days, people are renting bike more as compared to the holidays. Maybe like regular days, people may use bikes more for their work or students for their school or colleges. Like, and holidays, people may prefer to enjoy in their personal space. So that's why. So maybe the bike rental demand in non-holidays days are like holidays on holidays are reduced or less. So next chart is or next visualization is number of bikes rented at different temperature. We talk about different number of bike rentals on different seasons or holidays or non-holidays. Now talk about how temperature affects bike renting. So for this, temperature is a numerical data type, a numerical data type, numerical data. So I have used scatter plot, which is best for visualize the pattern. Okay. For this, I have used C1 library. For x-axis, I have used temperature. Is and y-axis, the target value, which is rented by count. So we can observe that from this chart that between 20 to 30 degrees Celsius, people people uses or more bikes or people rented more bikes. Let's talk about briefly. The highest number of bike is rented between 15 degrees Celsius or 20 degrees Celsius to 30 degrees Celsius, which is about 40,000 plus rentals. This range indicates that um, this weather is between the 15 degree to 25 degree Celsius weather is best optimal for biking. And the extreme cold or extreme hot weather is indicating the discomfort. So people rented less bikes. And rental increase with rising temperature up to a certain point. Rental drops sharply between beyond 25 degree, likely due to excessive heat. And our next chart is we talk about that temperature. Next, humidity. How humidity affect the bike rentals. For this also, as humidity is in percentage. For the data is in percentage or in numbers. So for this, I have used scatter plot as number just because it will effective to visualize easily. So we can see that from this chart we can gain that humidity percentage between 40 to 16. Bike rental has reached peak. Means the optimal humidity range is 40 to 16 percentage. So the steep drop in rentals is observed after 70 percentage year. From 70 or 80. You can take 80 humidity. This indicates that high humidity may discomfort for bike users. For this, I have some recommendations like focus marketing and promotional campaigns during periods when humidity falls between 40 to 60, where the demands in peaks, and offer discounted rides during low humidity mornings or other peak of off peak times to increase demand. And here, okay. I have used the is null functions to discover if there is any null value, but there is no null value, so there is no need to do any changes. For duplicate values, there is no duplicate values also. CMU outliers. To detect outliers, I have used a box plot, which is best to detect outliers. And outliers is to detect outlier, I have used only the numerical value columns. which is snowfall, temperature, solar radiation, humidity, rainfall, temperature, visibility. From this chart visualization, we discover that for rainfall, mostly low, heavy rain outliers may disturb bike rentals. Like temperature, moderate range, visibility, generally high or low visibility may impact safety or uses. And solar radiation, mostly low. Maybe cloud cover can affect rentals. And for temperature, best is 10 to 25 or 15 to 25. Snowfall, minimum. Occasional heavy snow can disrupt biking. Wind speed, generally low. Strong winds might discourage riders. Humidity, moderate is ideal. High humidity may deter biking. Here I have used IQR just because we have many numerical data. That's why I have used IQR. Means what is let's talk about what is outliers first. Okay, outliers are data points that differ significantly from the rest of the data and can skew the results of our analysis. One common method for detecting outlier is by using the IQR, which is interquartile range, which is range between the Q1 to Q2 means that first quartile to between first quartile and third quartile. Okay, so here store the first quartile in Q1, third quartile in Q3, and by my difference by finding difference we get IQR, which is like this, and we apply these calculations to each containing numerical data that may have outliers. Any values falling outside the range defined the upper and lower fences are removed. Null value. If there is any null values, then we will here I have used this filna too. Filna median, sorry, dot median to fill the data cell where uh, the data where there is no data, fill with the median value. Just because the imputation or the median is best for many data. Okay. After this, our next step is feature encoding. Let's talk about what is feature encoding. Machine learning models can only work with the numerical values, and therefore important categorical columns have to encode it into numerical values. This process is known as feature encoding. We will convert every categorical data into numerical data. Like here, for winter, if seasons, I have defined four encodings for winter. If winter is season is yes, then one, or else is zero. For also every seasons, for every unit values, there will one and zero. Like seasons, there are four unit values: winter, spring, summer, and autumn. For this, I will use the numbers. And after encoding, I will drop that seasons column to reduce the redundancy. Okay, for holiday, there is one or zero, either holiday or no holiday. Like this function day, I have two options only, either function day or no. So one and zero only. After encoding the all categorical columns, we get that these are columns like date entered by count, which is our target value, target column. However, temperature, humidity, wind speed, visibility, these are same like before. And from this, we explore holiday, functioning day, winter, spring, summer, autumn. Look, these are the catalysts or the values of object type. But now these are numerical type, which is way better which is best to convert for machine learning process. Okay, next I have just this is checking correlation for future removal. If there is any need of future removal. It says for when rented bike counter positively correlated with the temperature, negatively correlated with the humidity. For seasons, winter has a strong negative correlation with the temperature and rented bike count, indicating fewer bike rental in cold weather. Summer and autumn shows a moderate positive correlation with bike rentals. Our is a moderate correlation with the bike rent, suggesting higher rental at specific hours. Snowfall and rainfalls have a negligible correlations with bike rentals, but may impact users directly. Slight positive correlation with rented bike count, slight mitigating high rentals on operational days. Next is let's talk about what is multi-collinearity. Multi-collinearity occurs when two or more independent variables in a regression models are highly correlated with each other. This makes it difficult to determine individual effect of each variable on the dependent variable. So I will check the multi-collinearity of our dataset by using variance inflation factor accepted BIF is less than 0, less than 10. Okay. For this IDF columns, I have converted the list. After removing the rented by count, the rest of all columns will show in IDF learning directly. This small changes. Okay. After all this, XY. Let's talk about XY. What is X and what is Y? After drop rented by count from the DF, remaining all columns are in X and that particular one target column is in Y, is in variable Y. Okay. Okay. Next, then I have applying the square root transformation for a dependent variable, which is Y square root, and then I say Y. So after that, we split the data into two sections, training and testing data. X train, X test, Y train, Y test. I have split the data in 75 is to 25 percentage. After splitting, we can see that extend data set has total 6,570 rows and 11 columns, where X-test data set is 2,190 rows and 11 columns. So next is feature scaling. Feature scaling means it is a data processing technique used to normalize or standardize the range of independent variables in a dataset. This ensures that all features contribute equally to a machine learning model. So there are two ways for feature scaling, the minimum, maximum normalization and or standardization. In this process, I have used a standardization method to help standard scalar method. After standardization, fit transform, we get that extend and extend properly. Next, the main important concepts come model implementation. So, machine learning models can be described as programs that are trained to find patterns or trends within data and predict the result for new data. In this project, we are dealing with the regression problem, as I have told before. Therefore, we will be using regression models. The models includes linear regression, Reed's regression, Lasso regression, and random forest regression. Let's talk about each regression. Okay. What is linear regression means? In linear regression is a regression technique and it comes under supervisory learning, obviously. It performs the task to predict a dependent variable value I based on given independent variable values, which is in X variable. So this regression technique finds out a linear relationship between X and Y. Okay, for this I have direct use that linear regression function dot fit X train and Y train, and this is the code to find the values of X train, R square value, MSC value, MAE value, which is R square value is 0.48 for X train. Okay, MSE 79.4 and MAE 6.54. For testing, X test, R square is 4.5, which is nearly same, and 85.9, which is little difference. 6.54 and 6.7 nearly same. So the comparison of actual value and the prediction obtained by linear regression, you can say actual value is in blue line, predicted value is in orange dash line. You can see that there is only little differences. Okay. Next is ridge regression. Ridge regression is a model of estimating the coefficients of regression model in scenarios where independent variables are highly correlated. It uses a linear regression model with the L2 regularization method. For ridge regression, I have used L2 regularization method. Okay, for this grid search CV, I have used this function. And after the code, we get the value. You can see that actual value is in blue and predictor value is in this is some yellow type color. So almost the same as the linear regression. The value, let's check about the value. MSC value 86, which is also nearly the linear. MSC 9.27, that linear regression was 8.9 something. R2 0.45, same. Adjusted R2 4.5, this is also same. So we can see that there is only a slight difference between the results achieved through linear regression and the ridge regression, which is in MSE section, which was in in linear regression we have we got that 85.45 something, here 86. So just little difference. Next is what is lasso regression. Lasso regression analysis is a shrinkage and variable selection method for linear regression method. This will shrink the linear regression method. So this goal of the lasso regression is to obtain the subset of predictors that minimizes an prediction error for a quantitative response variable. It uses a linear regression model with L1 regularization. As I have told that this will uses a linear regression model, but this will find that subset the predictors from the linear regression. So we can say that this is a subset of submethods of lasso regression. So for the lasso function, I have creating a lasso regression model using read search CV, and to print the value uh, as the value for alpha gives us a negative mean square error minus 84 negative value. After printing that lasso regression, you can see that the actual and predictor actually is in blue lines and predictor is in which color is this or a yellow line. There are a lot difference as compared to the linear regression and ridge regression. So let's see the numbers. Oh, MSC. There are 85 and 86. There were. And here 90 point. And RMSC 9.49, which is nearly same. R2 point there in previously we got that 0.45 something, and here we got 4.429, and adjusted R2 for 2.66. So there is a difference in lasso regression and linear regression in this section, MSc section and R2 section. We got there 4.45, here 429. Slight difference. Okay. Okay, the random forest, what is a random forest regression? Okay, the random forest regression is a meta estimator that feeds a number of classifying decision trees on a various subsamples of the datasets and uses averaging to improving the predictive accuracy and control overfitting. This is also subsample. So let's for this random forest regressor, I use this random forest regressor function, and for this also grid searches of oh, we get that MSC is 947. In previous lasso regression, we get to some 92 something, and RMSC 6.9. Okay, near there we got 9 point something. R269, we got there 42. Value R2 is 69. Much difference. And adjusted R2 is 69.6968. So here we got the difference. Many differences compared to the last regression. Actually is in blue lines and predictor is yellow line. You can see that there are more and many similar in the actual and predicted values. So as you can see, the quality of model prediction is drastically improved. As we can see previously, with visualizations, there are difference between blue and orange lines. But as we improve the model prediction model, so we can see that in last forest regression model, we get that to similarity in orange and blue lines. So we getting improved models. Okay, so let's explain briefly. Okay, model explainability means the concept of being able to understand the machine learning model. For example, if a healthcare model is predicting whether a patient is suffering from a particular disease or not. So, popular technique for model explainability is LIME SAP EL1 score 5. In this project, I will be using SAP for model explainability. Among the various methods in SAP, I will be using SAP summary plot, which plot feature columns in order for their impact on prediction and also process values. For this, I have installed the SAP, define a function which is SAP underscore summary to in which to which is by way of model is a parameter. First, let's summary plotting the summary of a linear regression model. So SAP underscore summary linear regression model. You can see that here the divider line indicates that the difference of negative value, the comparison of negative value and positive values. In temperature, there are similar of negative and positive. Summer, we get more positive. Autumn, more positive. Hour is was similar for both positive and negative. Date numeric, it's not necessarily. For each model also, there is positive results more. And for last model, there is not this for this temperature hour and humidity we get positives, and for all these seasons we get almost nothing value to the nearly zero. And for this random forest regression we get value, we see the different importance or impact power is given to features by each model, and that defines how well the model performs on prediction. Random forest gives almost all features a significant impact power, and therefore it performs the best out of all models. Random forest here, the random forest, the last. Out of all the summary, this gives better result. So by looking at the sub summary of plot for each model, we can figure out the feature importance and also its impact power by understanding the sub values. Okay, for conclusion, EDA insights, what are the EDA insights? Most number of bikes are rented in summer seasons and lowest in winter. And over 96% of the bikes are rented on days considered on no holidays. Most number of bikes are rented in temperature range between 15 to 30. Mostly number of bikes are rented when there is no snowfall or rainfall. Majority of bikes are rented for a humidity percentage range of 30 to 70. The highest number of bike rentals have been done in the 18th hour, which is 6 p.m. and lowest in 4th hour, which is 4 a.m. So most of bike rentals have been made when there is high visibility. Okay. And the machine learning model results are like this. Random forest regression is the best performing model with n R2 square R2 score, sorry, R2 score of 0.6645. Excuse me. Lasso regression, I have used L1 regularization, is the worst performing model with score of 0.42. Actual versus prediction visualization is done for all four models, and all four models have been explained with the help of SAP library. Temperature and hour are the two most important factors according to the all models.